Swayam Prabha. Digital India. Educated India.
So, hello student, we will continue the same collection of solid waste module, and this will be the last lecture where we will again go for analysis of collection system. There is a part 3. So, in today's lecture as I explained in the previous lecture, we will compare the hall container system and stationary container system, but we will start with the one problem, one numerical first we will do, and based on the numerical we will try to compare the whether hall container system is beneficial or stationary container system, and also we will see the one of the very important parameter, based on that we can finalize whether to go for hall container system or stationary container system. So, we will directly go for problem, and the problem statement is a private solid waste collection vehicle located to MRF, a material recovery facility or recycling facility near a commercial area, okay, one private waste collector, and the collector would like to use hall container system, but fear that the hall cost might be prohibitive. I think as I also told, because there are a lot of hauling, and a lot of hauling means for every location you need to haul the vehicle to the recycling facility or disposal facility. But if you compare with the stationary container system, where only once in a route, one route has the vehicle will haul to the recycling facility or disposal facility. But what collector is fear that the haul cost might be more, okay, if he is going to use the hall container system. So, the question is that what is the maximum distance away from the commercial area that the MRF can be located, so that the weekly cost of the hall container system do not exceed those of the stationary container system. So, here what has been asked, we have to finalize the location of MRF, material recovery facility, in such a way that the weekly cost of the hall container system do not be exceed with the stationary container system. Means we have to finalize the x value, this is the what maximum distance, this is the x value we have to calculate, where round trip distance or one way distance we have to calculate, where this private collector will finalize the recycling facility or MRF center. And what the assumption is that the one collector driven vehicle will be used in the each system, and for the purpose for this example assume that T1 and T2 values are included into the off route factor. So, whatever the off route factor 0.15, which will including the time of T1 and T2, and these datas are given. So, this is for hall container system. So, the first is quantity of solid waste, that is 230 meter cube per week, container size, container utilization factor, pickup time, this is the PC is given, hall constants A and B, and at site time, overhead cost. So, overhead cost is given per week, and operation cost, okay, operation cost based on the per hour of operation. So, the normally the operations will be for 8 hour, okay, but cost is given for the 1 hour. Now, for stationary container system, the quantities are same, container size is also same, utilization factor is also same. Now, here the vehicle is given, okay, vehicle size, collection vehicle capacity is given, compaction ratio is given, unloading time UC value is given here, okay. and hall constant, here also the similar way operation cost also given per hour of operation. And also for regarding the location characteristics, the DBC value is given, average distance between the container location 0.16 kilometer, and also constant for estimating driving between the container location A and B values are given. Okay. So, now we will go for solution. So, first we will calculate the TW value or total time in a week, that will be how many days will be required in a week. So, the first we will determine the number of trips per week. This we can calculate by NW into weekly quantity of waste collected, how much quantity is getting collected on weekly basis, and we will divide by average container size. Okay. And this container size is multiplied by the utilization factor. By that way we can calculate how many number of trips will be required in a week. So, it is a very simple to understand, weekly quantity collected divided by container size. So, that will be VW divided by CF. So, 230 is the meter cube per week, that is a quantity is given, container size is 6 meter cube per trip, and into utilization factor, that is coming out to be 57 trips per week. Okay. This is number of trips per week. Now, we will estimate the average pickup time for hall container system. So, that is PC plus UC plus DBC. Okay. This is already known to you people. So, this PC plus UC. Now, here because now for DBC A and B are these constants are given, like you see in the problem. For this one, this A and B are given. So, to calculate the DBC value, we have to also use these constants. So, that will be a PC plus UC, in DBC case A plus Bx. Okay. So, here this is the constant, DBC constants A and B, and x is that 0.16 kilometer is given. So, from that PSCS we can calculate 0.133. So, here this unloading time is also is given, the PC is given and UC values are given in the problem. So, PC is 0.033 and UC is 0.033, okay, R per trip is given. Now, we will calculate the time required per week as a function of round trip haul distance. So, that this is the one formula we will use, TW is equal to NW into PSCS plus S plus A plus Bx divided by H into 1 minus W. So, it is time required per week and the unit will be the days per week. So, we will put up the value, NW we calculate 57, remaining value is also calculated, only we do not have the value of x, okay. And H we already know that H is 8 hour in a operation time in a day, and W is also 0.15. Suppose in the problem these values are not given, like capital H and W value off route factor, you assume, because every time this will be a H will be the 8 hour and W will be the 0.15. So, that is coming out 1.74 plus 0.12 x days per week. Okay. Now, we will calculate, determine the weekly operation cost as a function of round trip haul distance. So, this operation cost we can calculate by operation cost per hour, daily total hour operation and time required per week, that is TW value. If you multiply, we can calculate the operation cost. So, operation cost is given per hour operation cost, this is 8 hour daily operation and this is the TW value we calculated. So, this will be the equation will come up with the operation cost. Okay, 14,582.64 plus 1024.32 x. Okay. Now, the overhead cost is already given. Okay. This is given in the problem. So, the total cost will be overhead cost plus operation cost. Okay. So, total cost we can calculate by summing with the overhead cost. This is finally one equation will come up. The total cost is 43,046.64 plus 1024.32 x. This is the total cost value, okay, for hall container system. Now, we will go for stationary container system. Similar way, we will calculate the first we will calculate the TW value, total time required per week, that will be also function of round trip haul distance, and after that we will calculate operation cost and finally total cost. So, for stationary container system, first we determine the number of containers emptied per trip, that is CT value. So, this we can calculate by volume of collection vehicle divided by container volume. This is simply we can calculate number of containers emptied per trip if you know the volume of collection vehicle and if you know the container volume. So, we can know that how many containers could be fill up into the truck, okay, in a trip. So, that only is multiplying the for knowing the vehicle value volume where multiplied by compaction ratio, and for container volume we are multiplying by the container utilization factor. So, that is VR divided by CF. So, 23 meter cube per trip is a volume of the container vehicle and container volume is 6 meter cube. Okay. So, we are getting 11.44 and we will use 11 containers per trip. If it is more than 11.5, then we could take 12 containers per trip. Now, we will estimate the pickup time per operation, and we know that this equation PSS equal to CT into UC plus NP minus 1 into DBC. So, here in the last class I put it N is capital, okay, NP minus 1 into DBC. So, okay, here also you can put N. So, DBC is same A plus BX and we will put the value. UC is already given, and here also now this NP is equal to CT, that we assume 11. Why? Because the NP value are number of container on each location, it was not given. So, we just assume only one container in a one location. Okay. So, whatever the number of containers emptied per day, how many containers can be emptied per day, that similar will be the NP value. Okay. So, this value is comes up 1.22 hour per trip. Now, we will determine number of trips per week, that NW value. Okay, first that we can calculate by weekly quantity of waste collected divided by volume of container vehicle. They are also very simple. Number of trips required per week can be calculated if you know that weekly quantity of how much quantity of waste collected divided by volume of collection vehicle. Only we multiply the compaction ratio with that. So, 230 is already given meter cube per week, and collection vehicle is 23 meter cube. So, from that we can calculate 5 trips per week, that is the NW value. Now, we can estimate the time required per week TW as a function of round trip haul distance. So, this equation we already found in the previous lecture. Okay. So, where is the NW is the number of trips per week and is a round off of this small tw is a round off value of nw value. So, here because the only the nw is coming 5 trips. Now, here also we assume 5 is the round off value. If suppose this value comes to be 5.2, so we will round off by 5. If it is coming 5.8, we will round off by 6. Okay. So, once we put it all the data, we will get it this equation 0.92 plus 0.01 x days per week. Now, we will determine the weekly operation cost is a cost which is a function of round trip halt distance. So, in the same way we can calculate the operation cost per hour cost multiplied by daily hour of operation and multiplied by TW value for stationary container system. The same way calculated and it comes to be 10,473.28 plus 113.84 x value. So, overhead cost again the overhead cost is already given here and total cost will be the sum of operation cost and overhead cost, and finally, is the equation will come up the total cost 43,843.28 plus 113.84 x, that will be rupees per week. Total cost will be required for total operation of stationary container system. Now, we got two equations, one for Hall container system and other for the stationary container system. Now, what we will do? We will compare both the collection system because we do not know here the x value. So, what we can do? X we can assume 0, 1, we will go forward 5, 10 kilometer, 15 kilometer, 20 kilometer, 25 kilometer. Likewise, we will put the value in the both the equations, Hall container equation and stationary container system, and we will see that how much total cost will come up. So, I already prepared that. Once we put it the x value, different x value, this is the equation for Hall container system and this is the equation for stationary container system. Here you see that once your Hall distance is increasing, your the Hall cost total cost of Hall container system also will increase, and similarly initially it itself was very high compared to the for stationary container system was high compared to the Hall container system, and again is rising, but that rise is not that high if you compare with the Hall container system. So, what we will do here? We will plot the curve between x value round trip Hall distance along in the x axis, and y axis will be the total cost, and we will see that how this graph will change with the round trip Hall distance. So, we plotted this graph between the round trip Hall distance versus weekly cost, and surprisingly you see the graph here. The Hall container system for initially for up to around 20 kilometer, the total cost for Hall container system was lower than the stationary container system, and at point 22.84 kilometer, the cost of Hall container system and stationary container system will be same cost will be required. So, that was the what that private collector was looking that both the costs is similar, where they can locate the MRF facility or recycling facility. Now, student, please understand, every time we think that Hall container systems are very costly system, because for every location waste or vehicle has to be hauled to the disposal site. So, lot of hauling is required, but see here in this graph, for the smaller distance like for 5 kilometer, 10 kilometer, even for the 20 kilometer, the cost of operation of Hall container system was very low, but it is increasing very fast. But for the smaller distance like 5 kilometer, 10 kilometer was very low. But if you compare with the stationary container system, for the smaller distance itself, it has very high cost, but with the distance it is not changing. Okay, there is not much change. That is what actually the most of the developing countries following, whether it is a stationary container system or Hall container system is very difficult to finalize. But I think most of the developing countries follows the stationary container system. Why? Because you see that whatever could be the distance, whether is a 5 kilometer, 2 kilometer, or whether it goes to the 20 kilometer, still the cost is negligible change in the cost. But when you plan for Hall container system, for the nearby locations always is a highly economical Hall container system, but once you go for far from 20 kilometer, your cost will be very high in Hall container system. That is why I always propose for the Indian cities especially, wherever possible that or the locations near to the recycling facility or locations near to the disposal facility, try to go for Hall container system nearby location, and for the far locations or 20, 25 kilometers or 30 kilometers, 40 kilometers, do not go for Hall container system. Then in that case you can plan stationary container system with the compaction facility, compactor vehicle, or also can be planned one transfer stations nearby, so that entire waste will come to the one transfer station, and from that waste is getting hauled to the disposal site. So, and especially for the class 2 towns in the India, or especially if you take the district centers or taluka level, these kind of Hall container systems are highly beneficial. So, again you will see that, sir, is it possible that to have the Hall container system in the smaller cities, because you will be required special kind of vehicles. So, see, initially in the primary collection services itself, I had proposed that for the smaller cities, why not to use the auto tipper system or mechanical vehicle, smaller size mechanical vehicles, and which will directly collect the waste from the households and will goes to the recycling facility or disposal facilities. Need not to go for dustbins. Need not to locate the dustbin. So, it is possible that the smaller towns like talukas or smaller districts is possible to neglect the dustbins in the entire city by proper waste collection facilities by the mechanical vehicle, smaller size mechanical vehicle, and directly hauling of entire waste to the disposal site. Okay. Now, I think you properly understand that when you compare the Hall container system, is not only the cost basis, but is not only the distance basis, there are other facilities also are required, or other infrastructure facilities are also required to finalize the Hall container system or stationary container system. This is a one way of solving a problem. So, the problem your answer will be the 22.84, that is a round trip distance. So, around 11.4 kilometer will be the maximum distance where the private collector will finalize the MRF center or recycling facility. But there is a alternate way, we can calculate the x value. If you put both the values same, like total cost of Hall container system is same to the total cost of stationary container system, by that way we can come up with the x value. X also here the same value is coming 22.84, and that one way distance 11.5 kilometer is a answer of the problem. where private collector can plan or can have the recycling facility or MRF facility. So, need not to fear that the cost of hall container system or stationary container system will be high. Now, another very important discussion in the collection of solid waste, that is collection route. This is one of the very important issue for while collection of solid waste from the urban centers. And there are, I think I can't say is not possible to finalize so easily how to finalize the route. So, what corporation also used to do, based on their experiences they are finalizing, but now is good under Swachh Bharat mission, some of the cities they started the GPS facility onto the vehicle. So, we can map or we can plan their particular route, and if suppose the routes are not economical, we can time to time we can change their route, particular vehicle route. But here I will give few points, at least I think we can discuss few points while finalizing the collection route. So, the collection route use a heuristic method, or we can say is a common sense, based on the common sense, or also can say the trial and error method, what corporations used to do. Approach with the philosophy of collecting the most waste with least resources in the context of constraints such as equipment breakdown, holidays, vacation, good labor practice, and another few more guidelines. Okay. So, I think these few guidelines at least we can finalize before finalizing the collection route. So, the first is crew size and vehicle must be known and coordinated. This is the very important one, coordinated. So, this coordinated means if the vehicle have the GPS facilities, so anyone can locate them where the particular vehicle in the vehicle located in the different locations. Sometimes the vehicle is I think somewhere is more traffic, and you are finding that the vehicle are going to that particular traffic areas. So, from office itself we can call the driver and ask them, okay, do not go onto that way, we can change the location. Likewise, and you know that in India or even most of the developing countries, these vehicle drivers also they are lot of off route times, especially the unnecessary off route times they are spending, and here time is very important. So, there also we can with the GPS facility we can properly organize them, and we can locate them where if they are unnecessary they are extending the off route time. Next is the route should be begin and end near arteries or major roads. We can say arteries or major roads. So, obviously, this is one of the very important point कि whatever route you are finalizing, this route has to be whether you start or whether you finish should be in the from the very near to the or very close or to the major roads. So, that once the vehicle is getting filled up completely, directly can goes to the disposal facilities or recycling facilities. As another point is topographic and physical boundaries should be route boundaries. This is another very important point. Whatever topography of that particular area or physical boundary could be possible, like it is possible that some area is covered with the one particular road or particular network could be possible. That could be a route boundaries of that particular area. So, here one photograph you can see I think we can start from the topography. So, that we can start the collection from the top of hill and work downward to the hill. Okay. Once the vehicle is getting filled up, go to the downward of the hill. Okay. So, last container point should be near disposal site. I think in that case your T2 value will be very low, or otherwise your first container could be near to the disposal site. So, that your T1 value could be less in that case, and traffic problem should be dealt with early in the morning. So, this is also very important to know that whatever road we are finding the more traffic, need not to go such kind of vehicle, and you know that in the traffic area, if such kind of vehicles are goes, not only the odor issue, but if there some kind of leachate is coming from the vehicle, that will also can pollutate that particular area. So, it is good to have the collection system early in the morning. So, some of the cities like Delhi, Mumbai, even in Chennai, we found that waste collection is done in night or early in the morning, like 4 o'clock, 5 o'clock they are starting. So, that by 8 o'clock entire collection will get finished, because from 9 o'clock or after 8 o'clock schools are starting, offices are starting. So, you will find lot of traffic in that case, in that particular timing. So, it is good to finish the entire collection early in the morning, and extremely large load should be dealt early in the morning. This is also one important, wherever I think somewhere the festivals or some particular events has been finalized, where large amount of waste has been generated. So, I think that kind of large load or even construction or demolition waste should get collected early in the morning. So, to avoid the traffic issue. Okay. So, these are the few points, and also along with that few important points, like your vehicle should not be very close to the schools, should not be very close to the hospitals, need not to pass every time to the in front of hospitals, schools or some civil offices or some kind of government offices. Is not good to travel the waste collection vehicles in front of this kind of locations. So, try to avoid such locations also, and these kind of points is also changes city to city or urban center to center, could need to be changed and has to be finalized by the local authorities or local corporation based on their experiences, can finalize and time to time change the collection routes also. That is also very important point, is not to get fix only one route, time to time change and see that how best economically and without having problem with the local people, waste could get hauled to the recycling facility or disposal facilities. Okay, these are the few points where we can finalize the collection route. Also, I can give one module, like if you know that GIS softwares also could possible to finalize the collection route. So, you can read something onto the GIS, you can put into the Google, and you can do some Google onto the GIS, or some of the books also available. These softwares also could be possible to finalize the collection route of your collection vehicles. But I think again there are some physical parameters also has to be again has to be looked. So, use the softwares also, and time to time changes along with the whatever physical issues are in that particular city. So, what we will do? We will go for one problem and we will try to finalize one collection route. Okay. So, this problem statement is there is a layout is given of one particular residential area. So, this is the layout is given. Okay. So, here in the particular block 2, 6 and 12 number of residences each block. Okay. So, there are different blocks are there and different residence had been given into the each block, somewhere is 2, somewhere is 6, somewhere 12 residence are given. Okay. So, we have to plan the collection route for this residential area. And the service area map would be prepared as the first step layout of collection route, and they assume that the following conditions apply. So, the occupants per residence. So, we saw that we have 2, 6 and 12 residents, and for each residence the occupants are 3.5 persons, and collection rate 1.6 kg per capita per day, collection frequency once per week, type of collection service is curb, collection crew size is 1 person, collection vehicle capacity 10.7 meter cube, and compacted specific weight of solid waste in the collection vehicle, that is density is also given 320 kg per meter cube. Okay. So, we will go for solution of that. First we will calculate the how much amount of waste has to be collected and how many trips will be required. So, based on that trips we can finalize the collection route, and few constraints are given. No U-turns in the street, this is one of the important which is also need to be discussed while finalize the collection route. The vehicle should not have the U-turns. Okay. Where I think it is very difficult for such vehicles, such large vehicles to have the U-turns. And the collection from each side of the street with stand up right hand drive collection system. This is also important one. The vehicle have right hand drive collection system. Only once the vehicle have the right hand, they from that households only the waste is getting collected, not from the other way. So, we will go for solution. First development of data needed to establish the collection route. So, the first is determination of total number of residences from which waste are to be collected. So, the first we will see the residents. So, we see that we have the residence of 2, 6, 2 and 6. So, this is coming to be 16, okay. That are the 10 numbers, okay. 16 residents of 10 numbers, and for 36 residents of 4 number and 28 residents of 1 number. So, we can finalize the residents 332 residents in that particular residential area. Now, we will see the determination of compacted volume of solid waste to be collected per week. So, we know that volume per week we can calculate by residence into occupants per residence multiplied by solid waste collection rate and multiplied by 7 days in a week, okay. Because once in a week collection facility will divide by density or specific weight of solid waste in the collection vehicle. So, by that way we can calculate volume per week. So, the residents are 332, we calculated 3.5 persons in each residence, per capita their generation, and 320 is a specific weight of solid waste. So, by that way we can calculate volume per week 40.67 meter cube. Now, we will determine the number of trips required per trip. This we can calculate by compacted volume of solid waste collected per week divided by collection vehicle capacity. Okay. How much is the volume of waste collected per week divided by collection of vehicle capacity, can calculate. So, this we calculated compacted volume of waste collected 40.67 and collection vehicle capacity is 10.7. So, it comes to be 3.8. So, we will use 4 trips per week. Okay. Now, we will determine the average number of residents from which waste has to be collected on each collection trip. So, we have residents of 332 and number of trips are 4. So, for each trip we will have 83 residents per trip. Now, we will lay out the collection route by successive trials using the route constant cited. So, 4 typical route you can see here. So, now the first is this is the start route. So, the first route started by like this. So, now here see that here the waste collection by right hand only, the vehicle is travelling, waste is getting collected like this. Now, the dotted line is saying that there is no waste collection, okay, the dotted line. So, the vehicle will go like this, is going like this, you see here. Likewise, the operation, and you see there is no U-turn. Okay. Likewise, waste is getting collected and here the route will get end. So, this is the first route. Now, for the second route it will get start like this. And this will be the end of next route. So, you see here I think we plot already the routes. So, the effectiveness of the collection route can be assessed by amount of route developed by dotted line. So, in this case here you can see that here are 2 dotted line. So, means I think here is very difficult, every time the vehicles you either in the route 1 and route 2 both way that particular road has to be used multiple times. So, but I think is very highly efficient this route we can finalize, and you see here in both routes we avoided the U-turns, U-turns, and we tried that from every locations the waste has to be collected, and maximum time we tried that the vehicle has been travelled from once only in that particular road. I think, but I think still we have to use few roads in the 2 times or 3 times. Okay. So, based on that we can finalize the different collection routes. Now, here we took one example of starting collection route and ending another collection route. So, likewise for the entire city also we can plan, and every time also I propose that do not plan the entire city in a one part. So, always try to decentralize, even the waste collection system also could be decentralized. Some particular geographic area waste collection will be different, their routing could be different, even waste collection system could be different, whether hall container or stationary container system. Some of the different topographic area of the same city, your collection system will be different, even primary collection service could be changed, and based on that it's possible to finalize the collection route. And again is depend upon the what kind of experiences the local authority is getting. Based on that experiences, they have to modify. And also is very important that because waste generation is exceeding with year to year. So, based on that your infrastructure facility for the collection system or collection services also has to be improved. I will not say need to go for mechanical collection system only. Somewhere is very difficult to operate the mechanical system, their operation is difficult. So, it should be a mix of mechanical collection system or manual collection system, but I think we have to try that. If you are good into the collection, then only we can go for proper treatment facility or recycling facility, and also can we finalize the proper disposal facility. And why I am trying to share more onto that, because the collection only is taking maximum fund for the waste management. And if you improve the waste collection through the economical way or proper planning way, we can find some kind of money for the treatment facilities and for the disposal facilities also. So, with this I will finish this module, we are end of this module. Now, from next lecture onward, we will go for first transfer station. This is also I had shared few points onto that in my previous lectures. So, next lecture I targeted specially onto the transfer stations, and for then once the entire waste is getting transported to the or collected or transported to the recycling facility or disposal facility, then we can go for the treatment facility. Okay. So, followed by we will go for treatment and disposal. Okay. Thank you.